So first we'll discuss about the solid state topic. In the solid state, first we have about the properties of the solids, right? So what are the properties of the solids? Any one of you gonna tell me? What are the properties of solids?
So fixed shape and definite volume.
Fixed shape and definite volume. What about next?
The forces of
The force of attraction.
the force of attraction between particles in a solid is greater than liquids and gases.
Very good. Next.
They can solids have a definite shape and volume.
Okay. Solid has a definite shape and the volume. Good. Next. Remaining, Himavarshini.
Solids are of two types, crystalline and amorphous.
Okay. So what is the difference between crystalline and amorphous solid?
Sir, I mean crystalline solids, the solids are uniform in nature. There is no deformation, but in amorphous, it is not uniform in nature. They can be uniform for a short distance, but amorphous on a whole are not regular.
Okay, we have one special property name is there for that. Isotropic and the anisotropic. Right?
Yes, sir.
So what is the meaning of isotropy and what is the meaning of anisotropy? What is the meaning of isotropy and what is the meaning of anisotropy?
Don't know, sir.
In isotropic, properties of materials are identical.
In isotropic, properties of the materials are identical. So when you take the different directions, the properties of the materials will be same in all the different directions. Right? There is a isotropic in nature. Anisotropy means what? Whatever the physical properties are there, it is entirely different in the different direction inside the given solid. There is a anisotropy. Okay, so if you take the amorphous solids, they have the short range of order. Whatever the particles are arranged, it is only for the short range. When you take the crystalline solids, they have the long range of order. They have the high melting point and the boiling point. Right. Amorphous solids will have the low melting point and the boiling point. So these are the just basic things about the solids. But when you come back to the unit cell, the actual topic will start from the unit cell. So unit cell means what again? It is the smallest block of the crystal lattice. Right?
Yes, sir.
So when you repeat the unit cell in the three-dimensional way, it will form the space lattice. Yes or no?
Yes, sir.
If you take one space lattice, in that the smallest block is the unit cell, which will give all the information about the space lattice. Please mute your mic. Okay, so when you take the unit cell, total we have the 6 parameters. We have the 3 edges ABC, which is nothing but the length, breadth, and the height, and the angles. So alpha, beta, gamma, where alpha, beta, gamma is the angle between the length, breadth, and the height. where alpha is the exactly angle between the B and C, and beta is the angle between the A and C, and gamma is the angle between the A and B, right? So if we take this as a unit cell, again we have the different terminology or different terms in the unit cells. One is the edge, right? So which is connecting the two lattice sites in the given unit cell is called as an edge. Total, how many edges are there?
12.
12 edges are there. Next one is the face. So if you take any cube or the cuboid, how many faces will be there for that?
6.
6 faces. Next, how many corners will be there?
8.
8 corners will be there. Next, we'll come back to the diagonals along the face. Suppose if you take only one face, you can form 2 diagonals to the opposite side, right? Yes or no? You can form the total 2 diagonals for each face. So total we have the 6 faces. So 6 into 2, total we have the 12 diagonals for the each unit cell. In the same way, when you do the body diagonals, instead of 12, you'll get only the 4 body diagonals. Okay. So inside the body or inside the cube, we can draw only the 4 body diagonals, and edges are 12, so that we have total 12 edge centers, and complete cube is only one body. So we have only one body centered. So any doubts up to this?
No, sir.
What about the remaining?
No, sir.
Jafar, any doubts? Fine. So when you come to the unit cells are the 2 types. One is a simple unit cell. The other one is a non-primitive unit cell. Okay. So simple unit cell means what? Whatever the atoms or the ions which occupies only at the corners of the unit cell. So particles are present only at the corners, that is called in simple unit cell. Next one is the centered unit cell. So when you come to the centered unit cell, total we have the 3 types or 4 types. Any one of you can tell me how many types of centered unit cells are there?
Face centered, body centered.
Face centered, body centered. Next,
Edge centered.
end centered. So face centered means what?
An extra particles will be in a shell. In the corners, particles will be present, and on the face also particle will be present. Sir.
Very good. So when you take the face centered unit cell, we have the particles at the corners as well as at the center of each faces. So 8 corners will be there and total 6 faces will be there. So 6 faces at the center of each face, there will be 1 lattice point. So total 14 lattice points will be there in the face center. The next one, body centered. So what is a body centered? 8 at the corner and 1 atom will occupy at the center of the body. So 8 plus 1 is equal to 9. So 9 lattice sites will be there in the body centered unit cell. The next one is a n-centered unit cell. So in the case of n-centered, we have the total 8 corners will be there. Along with that, 2 atoms will be there at the opposite faces to each other. Right? So if you see out of the 6 faces, only any 2 faces will be opposite to each other. Remaining all will be in the adjacent to each other. Okay. So total we have the 10 lattice sites in the n-centered unit cells.
Sir,
Yeah. Yeah, Pravalika.
sir, could you please give me the rename option?
I will just change. Pravalika is fine.
Sir, sorry.
This Pravalika is fine, right?
Ah, yes, sir.
Yeah. Okay. So this is all about the centered unit cells. Now, any doubts in that?
No, sir.
Okay. So after this, the main topic is we'll start here. So this is a tabular column. Okay, that we'll discuss afterwards. But main the JE point of view, or the any competitive side point of view, or the board point of view also, these numericals are very important. First, we should know what is the contribution part of the each unit cell in the each lattice point in the given unit cell. So suppose if the atom is at the corner, what is the contribution part of that atom to the given unit cell?
1/8.
1/8. If the atom is at the edge,
1/4, sir.
the contribution part is only 1/4. If the atom is at the face centered, the contribution part is 1/2. In the body centered, fully atom will be there inside the given unit cell. So the contribution part is completely to that unit cell only. So it is a 1. Okay. You have to remember this compulsory because in the exam point of view, they will ask the formulas of the compound. They'll give A and B and they'll tell octahedral words, tetrahedral words and all. You have to remember this contribution part. Okay. Now, when you use the contribution part, so in the case of simple unit cell, we have only the atoms at the corner. So 8 atoms will be there at the 8 corners and each atom will contribute only 1/8, right? And there is no atom at the faces and the body centered. So 8 into 1/8 is equal to 1. So effective number of atoms, how many are there in the simple unit cell? How many effective number of atoms are there?
1.
Only 1 is there. What about in the FCC?
8 into 1/8 plus 6 into 1/2, 4, sir.
4. So Z value is 4 in the case of FCC. What about BCC? What about the BCC?
8 into 1/8 plus 1 into 1/1, sir. 2.
2. The ECC and center.
8 into 1/8 plus 2 into 1/2, sir. 2.
Again the 2. So HCP. What is the Z value in the case of HCP? It is the 6. Okay. The Z value in the case of HCP is the 6 because these Z values are very important in the calculation of density of the solids. There we use this Z value. Okay. Is it clear up to this? Or any doubts?
Clear, sir.
The next one is the density formula. So this is the density formula Z into M by A cube into NA. Fine. So where Z is the effective number of atoms present in the given solid, where M is the mass of the solid, A is the edge length of the given unit cell, Na is the Avogadro's constant. But so again, do you know the relationship between the A and R? Anyone?
Yes, sir.
Where A is a
A is the edge length, sir.
Edge length of unit cell.
R is the radius of particle.
Radius of atom.
Yes, sir.
In the case of simple unit cell, what is the condition?
A is equal to 2R, sir.
A is equal to 2R. You have to remember these conditions compulsory. In the case of FCC, what is the condition?
4R is equal to 2 root A.
Root 2A is equal to 4.
Yes, sir. 4R is equal to root 2A. Yes, sir.
Root 2A is equal to 4R. In the case
Yes,
of
sir.
VCC,
Root 3A is equals to 4R, sir.
root 3A is equal to
4R.
4R. Compulsory, you have to remember these conditions.
Yes.
Simple unit cell, we have the A is equal to 2R. FCC, we have the root 2A is equal to 4R. VCC, we have the root 3A is equal to 4R. Now, if you got the doubt how you got these conditions, please mute your mic. See here. If this is the unit cell, simple one. Simple means what? Atoms will be there at the corners only, right? This is one atom. This is another atom. So what is the A? A is the edge length. This is the A. So this is nothing but from here to here, it is the A. Okay. So this is the one R. This is the another R. So what is the condition in the simple unit cell? The edge length A is equal to 2 times of R. Okay. Clear now? How you got this condition?
Yes, sir.
The similar way, if you do for the face centered, suppose this is the face diagonal. Okay, one atom will be there at the face centered means what? Atoms will be there at the corners and atom will be there at the center of the face. This is the center of the face. This is one more atom. Okay, so total how many atoms are there along the diagonal? How many atoms are there? 3 atoms are there, right?
Yes, sir.
From here to here, 1 R. These are 2 R's because that is a diameter actually. And here to here, 1 more R. Total how many R's are there? 1, 2, 3, 4. 4 R is equal to. What's the length of the face diagonal? If you take this as a and this as a, what is this length?
Root 2A.
Root 2A. So root 2A is equal to 4R, right? The length of the face diagonal is equal to 4 R's. R1, R2, R3, R4, total 4 R's. This is for the FCC. Similarly, if you go for the BCC, they will take the body diagonal. There, the length of the body diagonal is equal to root 3A. So root 3A is equal to 4 R's. That's all. Simple. Understanding the conditions.
Yes, sir.
Is it clear for everyone? Adesha?
Yes, sir.
Yes, sir.
Yes, sir.
Himavarshini?
Yes, sir.
Jafar? Om Naidu?
Yes, sir. Clear.
Pravalika?
Yes, sir.
Clear?
Yes, sir.
Varsha?
Yes, sir.
Any doubts, Varsha?
No, sir.
Okay. So these are the 3 important conditions Now density formula you know, right, already? Shall we do the numericals now? Are you ready with your pen and paper?
Yes, sir.
See, if you want to get the good score in the exam, your calculation speed should be very fast. When your calculation speed is high, only you can able to score more marks. Okay, practice that first. Now we'll see who will be the first answers. Just wait a minute. So we start with the simple one. Based upon these conditions, FCC, BCC, and ECC.
Okay, sir.
One minute. So we'll take this problem. Copper crystallizes in a FCC lattice with a unit cell length of 361 picometers. What is the radius of copper atom? What is radius of copper atom? Option A, 128 picometers. Option B, 157 picometers. Option C, 181 picometers. Option D, 108 picometers. First, how many of you understand the question? Raise the hands in the Zoom meeting. Good, Adesha. Sorry, it's Adyasha or how to pronounce?
Adyasha, sir.
Adyasha. Okay. Good. What about the remaining? Pravalika, Varsha, Himavarshini, Jafar.
Option A, sir.
Option
Yes, sir. Option A.
Yes, sir. Option A.
A. Very good. What about the remaining? Fast. Himavarshini, Jafar, Pravalika, and Varsha. First, tell me which formula you have to use here.
√2a is equal to 4r.
4 hours.
Already they said it is a FCC unit cell, right? So it is a FCC unit cell, they already said. So what is the condition for FCC? √2a is equal to 4r. So already cell length is given. There is nothing but the a value. So they are already given the a value, that is the 361 picometers. They are asking us to find the r value. That's all. Yeah, good, Varsha. Got the answer, Jafar? So simple one, this is direct formula. Root 2a is equal to 4r. So where a is equal to 361 picometers. So root 2 into 361 is equal to 4 times of r. So r is equal to root 2 by 4 into 361,
Please.
128 picometers. First tell me, what is this picometers? What is the conversion factor? 1 picometer is equal to how many meters?
10 to the power minus 9.
Minus 12.
Minus 12. Okay.
Okay. So 1 picometer
Yes.
is equal to 10 power minus 10 centimeters. Okay. This conversion is very important. These two. Because most of the cases they will give the edge length in the picometers and they'll ask the final answer in the centimeters. So that the conversion is very important. Is it clear for everyone?
Yes, sir.
Varsha and Pravalika?
Yes, sir.
Okay.
Yes, sir.
Can I give one more problem? So again, we'll take the copper. It crystallizes in BCC with edge length of 502 picometers. Okay. Now find out radius of copper atom in centimeters. Tell me the answer. The question is clear for you, right? Is it clear or not?
Clear, sir.
Okay. Tell me the answer fast. So this time Varsha and Pravalika has to give the answer first.
Sure. 213.3 into 10 to the power minus 10 centimeters.
200.
13.3 into 10 to the power minus 10 centimeters.
Okay. What about the remaining? Got the same answer? So one got the 217, no, good. Varsha 215. Okay, approximately we'll get that much only. Fine. But what is the condition you have to use here? Root 3a is equal to 4r, right?
4R.
Okay. I hope everyone understands the concept now. Yes or no?
Yes, sir.
Yes, sir.
So next we'll do the numerical on the density itself directly. So be careful in solving the density numericals because you'll get the A cube value, right? So see the question properly. So lithium has the basis structure. The density is 530 kg per meter cube and its atomic mass is 6.94 grams. Calculate the edge length of the unit cell of lithium metal. What is the answer you have to tell? Option A 352 picometers. Option B 527 picometers. Option C 264 picometers. And option D 154 picometers. What is the answer? First, how many of you understand the problem? So good. Got the answer. Adesha. Yeah, it's correct, Adesha.
Sir, is it option A, 352 p.m.?
Sorry.
Is it option A, sir?
Yeah, option A. Got the answer?
Yes, sir.
Remaining. So Divya and Abhyasha got the correct. What about others? Yeah, Om Naidu, your option is also correct. 357. Remaining got the answer? Yeah, Himavarshi, that's also correct. Sorry, 237 now. No, it's actually not from 237. Please check your answer once again. Whether you have done any calculation mistake. If you got the answer, fine. Otherwise, please tell something so that I can solve it on the board, notepad itself. Remaining. It's simple. Just first, what you have to do here? So first, write the density formula. D is equal to Z into N by A cube into NEA. So already they said it is a BCC structure. So BCC Z value is how much? 2. 2 into M value. They have given already, it's a 6.94 by A cube. They have to find out the A only, right? So A cube into Avogadro's constant. What is Avogadro's constant? What is Avogadro's constant?
6.023 into 10 to the power 23.
6.023 or 6.022 into 10 power 23. This is entirely equal to 530 kg per meter cube. But we don't want in kg per meter cube, right? So we want in the grams only. So 530 into 10 power 3 by meter cube to centimeter cube 10 power 2. 1 meter is equal to 100 centimeters. So 10 power 2 whole cube. So what will happen? 530 into 10 cube by 10 power 6. So when you cancel out these things, you'll get 0.530. 0.530. So A cube is equal to 2 into 6.94 by 0.530 into 6.022 into 10 power 23. Simply if you solve it, A is equal to cube root will come. Cube root of 2 into, you can write 7 simply, approximate. This is 0.530 into 6.022 into 10 power 23. So you'll get the answer in the centimeters because we're taken here in centimeters, right? This is a gram per centimeter cube. So we'll get the answer in the centimeters. Finally, like we'll get the answer like 3.52 into 10 power minus 8 centimeters. The final answer will be 352 picometers. Understand? Clear?
Yes, sir.
Is it clear for everyone?
Yes, sir.
So calculation speed is only important in solving these numericals. Shall we go for next numerical?
Yes, sir.
So next one is an element crystallized in a structure having FCC unit cell of edge length 200 picometers. Okay, calculate the density if 200 grams of this element contains 24 into 10 power 23 atoms. So how many of you understand this question? Raise your hands. How many of you understand the question? Raise the hands. Only one. Okay, solve it. This is a direct formula only. They have already given the Na value and they have already given the edge length value also and the mass also they have given. Just substitute these value in the above formula, you'll get the answer. Do it fast.
So the answer is 41.67 gram per centimeter cube.
Yeah, correct. Good. Exactly how much you got? 41 point?
67, sir.
Yeah, correct. Yeah, there, Sham. It's approximately 42, correct? Good. Adhyasha and Mega, right? Divya, sorry.
Meghna, sir.
Yeah, Meghana. Good. Both of you got the correct answer. What would the remaining? Om Naidu, it's correct, but you got only 40. Check it in the calculation part. It's okay when you have the different options are there like 40, 50, 60, 70, it's fine, your answer. But if you have the options like 40, 41, 42, 43, it will be difficult. If you finish this, we'll start the new topic. That's the packing efficiency. Himavarshini got the answer.
Yes.
What is the answer?
242 I got.
42 you got. What about Pravalika, Varsha, Jafar? Got the answer or not? Pravalika, Varsha, and Jafar. So it's also simple problem, right? So already they have given the edge length as a value 200 picometers and the mass also 200 grams. And NA value they have already given 24 into 10 power 23. So density is equal to Z into M by A cube into NA. So they mentioned FCC. So FCC Z value is equal to 4. So 4 into 200 by 200. And they have mentioned the density, they didn't give anything. So here the important point is, we'll take the density in the gram per centimeter cube. So whatever the picometers they have given, you have to convert that in first. So A is equal to 200 picometers, or how we can write 200 into 10 power minus 10 centimeters. So the 10 power minus 10 centimeters whole cube into 24 into 10 power 23. Did you understand this calculation part? Is it clear this step?
Yes, sir.
Yes, sir.
This is the important one. How you are taking the A value, because you have to convert the units from picometers to the centimeters. Then only you will get the answer. So D is equal to 4 200 by 2 cube into 10 power minus 8, right? That means 10 power minus 24 into 24 into 10 power 23. So this and this will get cancelled each other. So 2 cube 8. 8 means 4 ones are 4 twos are 100. So 100 10 power minus 1. That means 1000 by 24. Is it correct calculation part?
Yes, sir.
So you get approximately 41.67 gram per centimeter cube. Fine. So these are numericals on the density formula. It is very important. Just calculation speed is very important first. Next, we'll go for the packing efficiency. What is the meaning of packing efficiency? Anybody? Or packing fraction?
Number of atoms which can be packed into an unit cell.
Packing efficiency or the packing fraction? Generally, we have one formula, simple formula. volume occupied by the all the atoms to the volume of the cube. Volume occupied by all the atoms to the volume of unit cell. Okay. Or else, if you want in detailed way, volume occupied by effective atoms into volume of an atom by volume of unit cell. If you compress this formula in terms of Z value and the N values, so volume occupied by the effective atoms is Z value into volume of the atom. Atom is something what the sphere. What is the formula for volume of the sphere? 4 by 3
pi r cube.
pi r cube by volume of the unit cell. Edge length is A. That means A cube.
A cube.
That means volume cube you can take, or you can take A cube directly. Okay, this is a packing efficiency formula. Clear? Now,
Yes, sir.
if you take simple unit cell, what is the Z value? 1. What is the A value?
2r.
2r. Substitute the value here. Packing efficiency is equal to 1 into 4 by 3 pi r cube by A is equal to 2r. 2r whole cube. That means this r cube and this r cube will cancel each other. We'll get 4 by 3 into 8 into 5. Yes or no? That means 5 by 6. 5 by 6 now how much? It's approximately equal to 0.52, that is 52%. The packing efficiency of simple cube is how much? You can say it is a 5 by 6, or you can say it as a 52%. Packing efficiency is equal to 52% or 5 by 6 in the case of simple cube. Similarly, will you do for the HCC and the BCC as a homework in the next class?
Yes, sir.
Okay. Do that one. Any doubts in today's class?
No, sir.
Yeah, Himavarshini will post the class timings in the class group itself. Tomorrow morning we'll post the class timings. Don't worry about that. Okay. So whatever the class timings and all, each and every class will post in the respective WhatsApp groups. Any doubts?